Now we will apply the Galilean transformation equations for different situations. That is, we will apply Galilean transformation equations for number 1, space interval, or we can say that for length. Interval means the distance between 2 points, that is length. Second one is time interval. Third, velocity. Fourth one is acceleration. Fifth one is force. So we will apply these equations for these parameters. And also sixth, conservation of your law of conservation of linear momentum, and last is law of conservation of energy. So we will apply these equations, a set of 4 equations for these 7 applications. First of all, space interval. So in first case, let there are 2 inertial frames of reference, x, y and z, that is S frame, and second frame is this one, O dash, this is x dash, y dash, z dash, and it is moving with velocity v, and this frame is called S dash frame. Okay, these are 2 frames of references, and we will consider space interval or length. So let any 2 points A and B, these are 2 points A and B. So we will find the length means distance between A and B. The point A is lying at distance is x1 from this S frame, and second point is distance of x2. The distance of A point is x1 and of B point is x2 from S frame. And similarly, distance of this O dash means distance of point A from S dash frame, this one is x1 dash, and the second is to B is x2 dash. Now the length or the space interval is space interval with respect to S frame, with respect to S frame. When we observe the length of this AB with respect to S frame, then the length is x2 minus x1. Okay, so this AB is x2 minus x1, this is AB. Also, with respect to S dash frame, the same length is measured with respect to S dash frame. It will become x2 dash minus x1 dash. It is also AB, because AB is written by 2 equations, x2 minus x1 or x2 dash minus x1 dash. Okay. Now we will find the relation between this x2 minus x1, that is length is measured with respect to S frame and length is measured with respect to S dash frame. So we can apply for second x2 dash minus x1 dash. I am starting from this dash frame. You can start also from the S frame. You will get the same answer. So this is the space interval in S dash frame. Space interval in S dash frame. Now we will apply the Galilean transformation equations we have already studied in the previous lecture, that is using Galilean transformation equations, that is x dash is equal to x minus vt. So I am applying the direct equation, or y dash is y, z dash is z, and t dash is equal to t. This is a set of 4 equations or Galilean equations. So we will apply these equations for solving this article. Now in this equation, in this article, there is only x parameter. So we will apply the first x equation. Y, z and t, these are absent in this article. Now the length interval x2 dash minus x1 dash, it is the length or space interval. So we may write this x2 dash from this equation, that is x dash is equal to x minus vt. So similarly, I am applying this x as 2, it will become x2 dash is equal to x2 minus vt, and minus this x1 dash, we apply 1 here. So it will become x1 minus vt. Okay. So this is the value for x2 dash, it is value for x1 dash. Now vt remains same, because v is the velocity of frame, it is constant, it will not vary with the particle, and t is also constant, t is same as t dash. Therefore it is x2 minus vt, and minus into minus minus x1, and minus into minus plus vt, and vt is cancelled with the vt, and it is x2 minus x1. So x2 dash minus x1 dash is same as x2 minus x1. So we can say that the length AB is measured in S frame, this one, is equal to the length made in S dash frame. It means length will not change, or there is no change in the length when we observe in S frame or in S dash frame. So there is no change in length, so it is called invariance. It is called invariance of length, or invariance of space interval. So the interval in between 2 points in the space is always constant. It is independent of the frame, either it is measured from S frame or it is measured from S dash frame. So this is our first article, that is invariance of space interval or length. Second one is time interval. So what is time interval? Again, there are 2 events which occur at different times. It is O, it is O dash. It is S dash, it is S. S dash is moving. It is X, it is X dash. Y dash, and Z, it is Z dash. There are 2 frames, S and S dash. Both frames are inertial frames, because we are studying only inertial frames. Now let the event which is occurred at this point, any event occurred at this point, A point, but it occurred at different times. It will occur firstly at time t1, then occur after some time, that is t2. So let any event which occurred at t1 and t2 time, let this event is maybe it is a light bulb. So let the light bulb will glow at 10 am, and after that, after some time, it will glow at 10.5, that is 10 am, and after 5 minutes it will glow again. So 10 am is taken as T1, and 10 and 5 minutes is taken as T2. So this is happened in S frame. When that event, same event, is observed by S dash frame, then this event has two readings, T1 dash and T2 dash. Okay, because observation is different, but the event is same. The same event is observed by S frame, it is by S dash frame. Same event is observed or measured by the person which is sitting at O, and the same event is measured by the observer which is sitting at O dash. This is called the different observer, or the same event is observed by the different frames. So the time interval, what is interval? T2 minus T1. First occur at first time, then occur at second time. So the interval between the two flashes, it is T2 minus T1, and it is T2 dash minus T1 dash. So it is measured in S frame, it is measured in S dash frame. Let it is taken as delta T, okay, delta T. So it is taken as delta T dash. Now we will correlate these events by using Galilean equations. So we will correlate, or we find the relation between these two parameters by using Galilean equations. So using Galilean transmission equations for time. Now I am using the equation only for time. I am not using for x, y, z, because it is an event of time. So the equation for time is t dash is equal to t. You know that, the fourth equation which we have already proved. So when you put this t dash, t2 dash, I am starting from t2 dash minus t1 dash from here. So you can start either from dash or from without dash. So I am starting from the event from dash. Now t2 dash, as we know that from Galilean equation, t dash is equal to t. It means t2 dash is also equal to t2. And t1, when we put 1 1 here, it is become t1. So t2 dash become t2, t1 dash become t1. So it means the time interval, this one, in S dash frame is same as the time interval in S frame. So again, it is invariance under Galilean transmission, or it is also called Galilean invariance. So this term is called as Galilean invariance. Means the parameter which does not change with respect to S and S dash frame, it is called invariance, which cannot vary. Okay, invariance. So this is second. Time interval is also Galilean invariance. Next, third one. Third one is the velocity. What is velocity? You know that the rate of change of displacement is called velocity. So we will use the concept of derivative. It is derivative of displacement, or position. So I am using direct equations, Galilean transmission equation. In all articles, you have to use these equations. X dash is equal to x minus vt, y dash is equal to y, z dash to z, and t dash is equal to t. This is a set of 4 equations, that is Galilean transformation equations. Now to find the velocity, we will do the derivative. First, second, third, and fourth. Fourth is nothing, it is time. So velocity. So we will use first, second, third, and fourth. Like the fourth, we cannot find the velocity from fourth. We find velocity from 3. It is velocity x component, velocity is y component, velocity is z component, and t will be used for derivative. So we will do derivative, that is differentiating equation number 1 with respect to t. So it is dx dash upon dt is equal to dx upon dt minus d of vt upon dt. So I did actually derivative. It will become dx dash upon dt is equal to dx upon dt minus dvt upon dt. Now dx dash upon dt, this is velocity x component in s dash frame. It is taken as ux dash. So I have using, as I have written, dx upon dt as u. Why u? Because v is the velocity of frame and u is the velocity of this particle. U and u dash, these are the terms used for velocity of the particle, and we have reserved v as the velocity of frame. So there are two different things. One thing is particle, second thing is frame. So you must differentiate these two parameters, that is for particles and for frame. Frame is different, particle is different. So this is ux dash, dx upon dt, it is ux minus, now dt of vt. What is v? V is the velocity of frame. As you know that the velocity of frame is constant. Okay, it is uniform because it is constant. So this constant will come out v, and dt upon dt is 1. Okay. So this is the formula for velocity. Velocity is velocity of particle in s dash frame along x axis is equal to velocity of particle along x axis in s frame and minus velocity of frame. So this is for particle, this is for particle, this is for frame. So this is first parameter, and velocity is x component. Similarly, we can find for y axis. So we know that y dash is equal to y is second equation. So taking derivative means differentiating with respect to t on both sides. It is dy dash upon dt equal to dy upon dt. So dy dash upon dt, that is uy dash is equal to uy, second. And similarly, third component, that is z dash is equal to z, and we will do the derivative on both sides and we will get u z dash is equal to uz. This is third component. So it is set of three components for velocity, that is ux is equal to ux minus v, and y dash is equal to uy, and uz dash is equal to uz. From this equation, it is clear that the second component, third component, they are remain same, they are invariants, but the first velocity, first component is variant. So overall, the velocity is variant. Velocity is variant. So it is Galilean variance. It is not invariant, it is variant. So in our next lecture, we will find the equations for acceleration and force. Thank you very much.